if two lines are parallel, they look like railroad tracks. If two lines are parallel, they will have the same slope. Exactly. It will cause them to never, ever, ever cross. So let's see if I can sketch that for you very briefly here. Let's say I have this line, and then I have this line, and hopefully I eyeballed that pretty well, but those are parallel lines. They have the same slope. So let's say the equation for the first line, well, if I make up something really quick, it might be inaccurate and you can actually see lines, and I don't want to confuse you. But let's say the slope of the first line, which I did not happily line up nicely, but let's say the slope of the first line, the top line is 2, the slope of the line below it will also be 2. Okay. All right, so the next thing that you need to know is that perpendicular lines have opposite, reciprocal slope. So what does that mean? Well, perpendicular lines cross exactly like the axes do. The vertical line and the horizontal line are perfectly perpendicular, right? So let's say I have, let's see if I can draw a line here that is maybe somewhat straight. Yep, of course I. Okay, and then I have no idea if I can do this. All right, you kind of get that idea. Hopefully, oh no, I mean parallel lines. Okay, another example of parallel lines. Aren't we lucky? It's not what I meant to draw. I wanted to draw perpendicular lines. I'm not sure those are perfectly perpendicular, but if they were, this would be a right angle, right? So would every other corner there would be right angles. So lines that perfectly cross like that, they make a perfect X, they make 90-degree angles, have opposite reciprocal slope. Also, if I multiply them together, so the slope of the first one times the slope of the next one, which is going to be negative 1 over whatever that is, I will always get -1. So let me give you an example. So let's say I have y equals 3x. And I'm not going to put plus b, let's make it a direct variation. And let's say the other one is y equals opposite negative, right? Because the first one was positive. And then reciprocal just means it's going to be turned kind of upside down, right? So 3 over 1, the reciprocal of that is going to be 1 over 3. All right, so the slope of this line is 3. The slope of this line is -1/3. They are perpendicular lines. And look what happens if I actually multiply these numbers together. This is a quick test if you want to know if two slopes are perpendicular. If I were to multiply these, notice we go cancel, cancel, and then I just have a positive times a negative, and the whole thing becomes -1. Type it in your calculator if you want. But these are perpendicular lines. So why is this important? I mean, we can know that parallel lines have the same slope. we can know that perpendicular lines have opposite reciprocal slope. Make sure you get both. You have to do two things. Opposite means change the sign, and reciprocal means flip it upside down. Make it a fraction if it's not a fraction, and then flip it. Why is this important? Let's see if we can't look at some example problems in the lesson. So this lesson starts on page 239. And if you want to work through the examples, that would be great. You can look at those. And then if you look on page 243, it asks us to do some things like write an equation in slope-intercept form. I'm going to look at number 11 here. Write an equation in slope-intercept form for the line that passes through a given point and is parallel to the graph of the given equation. And so they give us a point, and then they give us an equation. Okay, the only reason they give us this equation is to find out what our slope is. And once we find out what our slope is, we're going to just throw that away. Because that line, the only thing it's doing is it is going to tell us our slope. Okay, if our slope is parallel to that one, then we need to find out what that guy's slope is. That's in y equals mx plus b form. M is a little mysterious here. It's a 1. M is 1. And our line is parallel, so we know that our line is going to have the same slope as that one. So now we know that the equation, in our equation, we're going to use slope of 1, and then we just toss this away, guys. So don't let it confuse you. We just use it and then throw it away. The only purpose it has is to help us find the slope that we want. So then we go back and we use the things we know. So if I have a point and I have a slope, I typically use the point slope form. And I'm going to say y minus negative 2 equals slope times x minus 3. Okay, that's y minus y1 equals m times x minus x1. Okay, and then you just have to look and see if it says slope-intercept form, because this happens to be point slope form. Not a problem. Notice that we have minus a negative, so I'm going to have y plus 2 equals, and then 1 times all of this. The distributive property is super easy. Then I'm going to subtract not some mysterious 3 that doesn't exist. I'm going to subtract 2 from both sides so that I get y equals x minus 5. And this is the equation that I was looking for. This is the line I wanted to talk about. Not this one. That one we just throw away because we don't need it. All right. What else can we have to do with this? I want to jump down to number 23 because sometimes we're asked to write an equation in slope-intercept form for the line that passes through the given point and is perpendicular. So I have this point now, great, and I have this equation, and my line is perpendicular. This is the sign for perpendicular. And so what I have to do is use this to find slope. That's the only value of it. The slope of this equation is negative 2. Can you see that? Y equals mx plus b. If the slope of this equation is negative 2, then the perpendicular slope for my equation is going to be the opposite, which is going to be positive, and the reciprocal, which is going to be 1/2. So opposite, change the sign. Reciprocal, flip it over. Negative 2 is the same as negative 2 over 1. So I can flip that over and go like that. Change the sign. Opposite, reciprocal. Then I'm just back to writing an equation. Y minus negative 2 equals slope times x minus a negative 3. It said slope-intercept form, so I have to do a little bit of rearranging. Y plus 2 equals 1/2 x plus 3/2. And then I'm going to subtract 2 from both sides to get y equals 1/2 x. 3/2 minus 2 would be 6. No, that's a 3. 4, sorry, 4/2. So I get negative 1/2, and that should be the right equation. Yes, okay. And this is what I want. So notice that this wasn't a big deal right here. All I did was use this to figure out my slope. Based on whether or not they tell me parallel, then it's the same, or perpendicular, it's opposite. So I'm going to have to do both. Write an equation as if my line is going to be parallel to the equation they gave me, and then write in a line as if mine is perpendicular. You can do either or. There are some other applications here. We can test to see if things are perpendicular or parallel. I'm trying to keep this under the allotted time, but let's say I was looking at number 33, and I have y equals 4x plus 3, and I have 4x plus y equals 3, and it asks me whether it is parallel, perpendicular, or neither. Well, I have to find the slope. The slope of this one is 4. The slope of this one, if I subtract 4x, I can look at this as y equals negative 4x plus 3, and then I know that the slope of this one is negative 4. Well, they are opposites, but they are not reciprocals. So they are not the same, so they're not parallel. They're not opposite and reciprocal, so they're not perpendicular, so they are neither. So that's how we test those. There are some other applications there, and I will try to pick up the explanations for those in the help video for your homework. So, to review, going back here, y equals mx plus b is slope-intercept form. Ax plus by equals c is standard form. Y minus y1 equals m times x minus x1 is point-slope form. We know that two lines are parallel if they have the same slope. We know that two lines are perpendicular if they have opposite reciprocal slope. So go ahead and work your exercises in Alex, see how that goes. I'll post a help video for that, and let me know if you have further questions.